Okay, in the last video, I have explained about how to find the modulus and the argument of a complex number when it is of the form a plus ib and when they carry positive negative signs. That is, both are positive, both are negative, real part positive, real part, sorry, imaginary part positive, and such cases. Now, what I'm going to explain is how to find the modulus of the quotient of two complex numbers. So, we should understand that the modulus of the quotient of two complex numbers is equal to, oh, I'm sorry, it is quotient. This is quotient. I have to do for product first and then I will do for quotient. So, the product of two complex numbers, that is, if Z1 and Z2 are two complex numbers, then the modulus of the product of the two complex numbers will be mod Z1 times mod Z2. That is, I'm going to write the same thing in words. The modulus of the product of two complex numbers is equal to the product of their moduli. So let me take two complex numbers to explain the situation. That is, if Z1 equal to 3 plus 4i and let Z2 be equal to 1 minus I am going to find out what is Z1 times Z2, find the modulus of it, and get the modulus of Z1 separately, Z2 separately, and show that the modulus of the product is the same as the product of their moduli. Z1 times Z2 will be 3 plus 4i times 1 minus I, which can be written as 3 minus 4, because I will always suggest that when you have to multiply two complex numbers a plus ib and c plus id to get the real part, don't you see that it is ac minus bd, because ib times id will be I square times bd, which will be the same as minus bd. So it will be ac minus bd. Hence, in this case, it will be 3 into 1 minus 4 into minus 1. So this will become plus, and plus I times 4 into 1 plus 3 into minus I, which will give you 4 minus 3. Therefore, the product of these two complex numbers turns out to be 7 plus I. Now, let me find out the modulus of this. Will it not be 49 plus 1 under root, which is 50 under root, which is 5 root 2. Now, let me see what is the modulus of Z1 and Z2 separately. Don't we see that mod Z1 equal to 3 square plus 4 square under root, which will be therefore 5 square under root, which will be 5. And mod of Z1, Z2 is 1 square plus minus 1 the whole square under root, which is equal to root 2. Therefore, don't you see that the modulus of Z1, Z2 equal to mod Z1 times mod Z2. That is what we have proved here, that the modulus of the product of two complex numbers is equal to the product of their moduli. Now let me clear off this and explain how it works for quotient. It will work the same way for quotient also, like mod of Z1 upon Z2 will be equal to mod Z1 upon mod Z2. I can take the same Z1 and Z2, or I can choose something different. Let me choose something different. And this also I am going to write in words, that is the modulus of the quotient of two complex numbers is the quotient of their moduli. Quotient of their moduli. That is, moduli is the plural for modulus. Okay. Let me take an example of let z1 be equal to root 3 plus I and z2 be equal to 1 minus root 3I. Some random example I'm choosing. And so I'm going to now find out what is z1 upon z2 and then find the modulus. So let me first find out what is z1 upon z2. That is going to be root 3 plus I upon 1 minus root 3I. So since I have to eliminate the I in the denominator, I am going to multiply up and down by the conjugate, which will be 1 plus root 3I multiplied up and down. And what is this going to give me? As I have told you for the previous case also, now to get the real part, I multiply real with real and imaginary with imaginary, which will give me root 3 into 1 minus, since it is I square, it is minus root 3. So it seems that the real part becomes 0. And for the imaginary part, it is imaginary into real, which is 1, plus real into imaginary, that is root 3 into root 3I, which will become 3. And the denominator is it not going to be of the form a plus b times a minus b, which is a square minus b square, or 1 minus 3I square, which will therefore become 1 plus 3 or 4. So what I now get is 4I by 4, which is equal to 1. And what is going to be the modulus of this? It has only the imaginary part, it has no real part. So will it not be 0 square plus 1 square? 0 square plus 1 square under root, which is equal to 1. Now let me see what happens when I'm finding it out separately. Now mod of z1 will be root 3 the whole square plus 1 square, which is 3 plus 1, 4 under root, which is equal to 2. I have to put a root for this also. Whereas mod of z2 is going to be equal to 1 square plus minus root 3 the whole square under root, which is therefore going to be 1 plus 3, which is 4 under root, which is 2. Therefore, don't you see that mod z1 by mod z2, mod z1 upon mod z2 is going to be 2 by 2, which is equal to 1. Hence, we have proved that the modulus of the quotient of two complex numbers is the quotient of their moduli. We can also prove this using some not numericals. We can take it as a plus ib, c plus id and proceed. That also I am going to put up in the next video. That is the general case. That is not numerically. It is going to be taken as the complex numbers are going to be taken as a plus ib and c plus id. I will proceed on what is z1 times z2 and z1 upon z2, and I will show that the modulus is same as what I have put for here.